Hey everybody, my name is Ian Cooper, and hopefully you've come along today to hear about modeling with responsibility-driven design. Can I just ask a couple of quick questions? The first is, before you'd read, say, the abstract for this agenda of this session, etc., who'd heard of responsibility-driven design? Just sort of one person, I think. Yeah, okay. That's probably about fair. That's what I would kind of expect. Who's heard of domain-driven design? Okay. And of those people that put their hand up saying you've heard of domain-driven design, the thing I have to tell you, right, is that if you think you are doing domain-driven design and you do not know what responsibility-driven design, you are not doing domain-driven design. And I will explain why that is true. This just means I'm old, right? It's off my LinkedIn. It's very unexciting. Any .NET developers in the room? I work on an open source messaging stroke CQRS framework called Brighter. We can replace Mediator and Mass Transit. We are older than Mediator. We predate Mass Transit as a messaging framework. We cover a lot of scenarios and use cases. We are used at scale. We use it at my current gig. We send over 1.5 billion messages a day. So pretty well battle tested. All right. So we're going to talk about today. We're going to talk about responsibility-driven design. We're going to explain how it fits into domain-driven design and what it's for. We're going to run through responsibility-driven design in more detail. How would you use it? Then we'll do a worked example of using responsibility-driven design on a problem space to see how it looks. We won't cover much about RDD today. That's really if I've got like an hour. I'll mention it a bit if I've got a few seconds at the end. Okay. So hopefully this is a refresher for you. So in 2004, Eric Evans produces the Blue Book for domain-driven design. And Eric's key proposition, I would say, is that we should focus our energy as software engineers on modeling the domain and not modeling the application. And by that, what it really means is our focus shouldn't be on technical concerns, such as how do I persist this to a database? How do I expose an API that lets me accept REST calls? But actually on the domain model that the customer wants to implement. As an aside, I think that's going to become even more important with the impact of Gen AI on our industry. Our sweet spot will be modeling the domain with the customer and less about that periphery which can be generated. Anyway, Eric, by the way, if you don't know, is very positive about AI because he sees that kind of change. And one of the chief things we want to do is isolate the domain model from application concerns. And we express a number of patterns. We talk about things like layers and ports and adapters of ways of doing that. We want to have this clean, if you like, area where we can basically domain model to our heart's content without worrying about technical concerns. And one of the key ideas is that we will create a ubiquitous language for the domain model. Interestingly, that is not simply the language of the customer, but that is a shared language that we and the customer have to define concepts in the domain. We may have many ubiquitous languages in an organization. So one of my canonical examples would be in an insurance company, you may have a ubiquitous language in the claims department and a ubiquitous language in the underwriting department. They may talk about things like policy or risk or a clause. They may use similar language, but they may mean very different things by that in their context, right? They care about different properties of that. From a point of view of a claim, you care about someone wants to basically get some money off me for their insurance. From the point of view of underwriting, what kind of risk are you? And that model needs to be expressed at all levels. So the team use it in conversations. When we write code, the terms and words we're using from that are expressed in the classes, in the database schemas that we have. Once upon a time, most of you may not be old enough to know this, but we had actually some different models we used at different points in the process. So you took a use case, and you often express that use case as what we called an analysis model. An analysis model had things like boundaries, controllers, entities, etc. And it was a high level abstraction of what you were doing in the use case. And you would then convert that into a design model, which was where you got into things like UML, right? And Eric's proposition was let's just have one model. One model, and what we care about is the model of the domain, not all these application concerns around the edges. Okay. And so most of you, I suspect, will be familiar with this kind of diagram, which talks about DDD in terms of repositories, entities, value objects, aggregates, factories, right, services. And this key notion of we're doing model-driven design. In other words, we are essentially driving everything by the domain model that we are focused on, right? Okay. But interestingly enough, if I look at that, and that's really the first half of the book, the second half is all about large-scale stuff, so it doesn't have any answers either. A lot of those ideas are twofold. The first one is really they're about expressing the lifetime of domain object. It's born in a factory, it lives in a repository, it's comparable with entity or value, it may preserve invariants. But that doesn't actually tell us very much about how we do modeling of the objects. Where do we find these entities? How do I know what the value objects are? Right? Where do they come from? They come from the domain, sure, but that's a bit meaningless, right? It just says, oh yeah, in your domain there are objects. Yeah, but how do I find them? Right? DDD doesn't really say anything at all about it. There is a comment basically in model-driven design which says you should assign responsibilities based on the domain model. And that's about it. That's about it. It's just some advice of how we actually create a domain model. And it seems like a very curious gap, right, for a book that says our focus is on model-driven design, on creating a model of all these objects that are interacting. It doesn't explain how we do that. There are examples where Eric is working through worked examples, but he doesn't at any point explain how to do it. As a result, most people who use the domain-driven design book without understanding what they're missing, and particularly people in 2025, put the book up 20 years later, will tend to focus on data modeling, essentially. So what data do I need to store around things, right? Drive everything with data, I'm storing this, I'm storing that, so I'll wrap classes around them, right? Often it's very focused on, the first thing I want to do is think about the classes that I will need, or I'm just going to interact with my framework. Another common approach is, I'll just think about the nouns. What are the words for things in my domain, right? My domain has a claim. That must be an object in my domain, right? And that's very typical. It also leads to very poor OO outcomes. There's a part of the domain-driven design book which most people probably miss, and 20 years after it was written, and that is not surprising. And it says, the design style in this book largely follows the principle of responsibility-driven design put forward by Worth-Brock et al. In 1990 and updated in Worth-Brock 2003. So he explicitly tells you that what you need to do is use responsibility-driven design in order to model the domain. He doesn't bother to tell you what that is, because obviously there is other information on that. So the time in 2003 when this book comes out, the dominant paradigm in the 90s, really when we think about object modeling, has been responsibility-driven design. The problem is that now, 30, 35 years later, that is not common knowledge, that essentially the book is built on this foundation which it doesn't feel it needs to explain to anybody. All right, so let's talk about responsibility-driven design. Let's try and fill in the gaps for you of what is the foundation that DDD sits on, right? So responsibility-driven design was first described in a paper by Rebecca Worth-Brock and Brian Wilkinson called Object-Oriented Design, a Responsibility-Driven Approach, and it was presented at the Uppsala Conference in 1989. In 1990, they produced a book based on that work called Designing Object-Oriented Software. And in 2003, Rebecca, basically a new collaborator, produced Object Design, Roles, Responsibilities, and Collaborations. That 2003 book is freely available on Rebecca's site. You can just go and download it nowadays. So it's very easy to get hold of and to access. And I can guarantee your LLM of choice will have ingested that book as part of its slurping up of all human knowledge. All right. So this book is effectively what Eric's referring to and the methodology it espouses. Okay. So what is the key idea of responsibility-driven design, right? So responsibility-driven design specifies object behavior before object structure and other implementation considerations are determined. We have found that it minimizes the rework required for major design changes. So the key idea to take away here, and we'll explore it in more detail, don't worry, is that what we want to think about is behavior, not structure. And by that we mean I want to think about the things that I model in my domain in terms of the behaviors that they have, not in terms of, say, the data that they hide or how that is actually implemented. Right? I also talk, many of you may know me from talks about test-driven development. This goes back to exactly the same problem, where we say TDD needs to focus on the behaviors, not on the structure and the implementation details. So key idea to succeeding in OO at all levels is to focus on behaviors. Okay. So the principles for responsibility-driven design are maximize abstraction, which is to allow the distinction between data and behavior. And we think about responsibilities that we have, knowing, doing, and deciding. We want to distribute behavior. We don't want God classes that basically everything has to talk to do things. In fact, we don't want completely dispersed, where effectively we say every single object does its own thing without any real idea of collaborating with others. What we want is a distributed control structure where we have objects that hold important parts of our behavior, and they have a small set of collaborators with them that help them actually do that work. Okay. And we want to preserve flexibility, so we design our objects so that we think a lot about the interfaces that they have with everybody else and less about their details, which enables us to change those details if we need to. Again, that comes back to really the TDD point. So we can think about this hierarchy. An application is a set of interacting objects, where application is anything, web app, CLI app, whatever you're building, agent. An object is an implementation of one or more roles. A role is a set of related responsibilities that can be used interchangeably, right? A responsibility is an obligation to perform a task or know information. So then one of the important ideas before we move on is to get this idea of, we identify, remember I said to you, Eric said, find the responsibilities in the domain and assign them. This is essentially what he's referring to. He's saying, we find our responsibilities and we essentially wrap those up into a role, which has basically a set of related responsibilities, and an object implements that role. So collaboration is where multiple roles interact. Obviously, we want to be distributed, so we don't want to have just one role, right? And a contract is agreement defining, outlining the terms of that collaboration. In other words, typically, that is how we define, say, an interface or an API or those kind of things. Right. Quick refresher, what's an object? When we mean object, what are we saying? Well, we're saying effectively we have some kind of factory for objects called a class. We have some data that we store inside it, typically a whole lot of private data. We may expose some public data. One of the weaknesses of very much that's happened to OO over time is a lot of people just writing getters and setters everywhere, right? And that's a bit negative because it just exposes all your data. Private and public methods. So the public methods are your behavior. Private methods are basically how you support your behavior. So a class couples data and behavior, and the data tends to be the data we require to support that behavior. All right. So we can do composition. My class can contain other classes in order to do its work, and we have inheritance, which we use less, which is a class can inherit behaviors from a base class. We use that less because it can become fragile. We have a thing called dynamic dispatch, which means basically that we can derive types from this class, call a method, and we will be dispatched to the one on particular implementation. And we work by a thing called message passing, which is not messaging as in RabbitMQ, etc., but is this idea that I send a message between two objects. So what's a responsibility? Okay, it's the behavioral contract of an object. And we define responsibilities as knowing something. So I know how to do a thing, right? Or rather, I know about data typically. So I know about the clauses on this insurance policy. Doing something, right? I know how to actually make something happen. And deciding something. I can make decisions and give you results back. You can ask me a question, and I will give you a response. Responsibilities are not methods per se. We find the responsibility in the domain, but our methods will most likely be based on the responsibilities that we have. So a role is a set of related responsibilities. They are the abstraction targeted by a collaboration. So multiple things may implement a role within our system. So it may be that multiple things are capable of dealing with that particular problem, right? And an object may have multiple roles. My object may actually have multiple roles that it performs. And it may be expressed as an abstract type or an interface. I know that it's become a little bit in vogue of late to say, no interfaces, we don't need them, right? I would move away from that thinking. I think that is not well reasoned about. Interfaces can represent roles very easily, and because they therefore represent roles, you can show that this particular class essentially supports these roles. And these roles are things in the domain that I am capable of doing, right? So that is what other people will take dependencies on. And you may have multiple roles, so the breadth of your methods on your class may be greater than one role, but I only need to depend on the things that essentially I want to collaborate with. So it's useful to have multiple roles because I don't have to depend on all of your methods, just on ones that I care about. So some information hiding there, right? So that's really what interfaces are for, is representing roles. I occasionally write roles using the capitalizing on the I syntax to write things like I have a, I am a. And I am a is quite common. It basically says I am a claims adjuster, right? I'm expressing my role within the domain. Stereotypes represent what we call structural roles. So within our application, we have some things that perform structural roles, and stereotypes are just a common list of things that we can use as a shorthand for given roles that you perform. They're not domain roles, so you need to be careful not to just rely on structural roles, right? But typical structural role is an information holder, right? So I know some information, and I may provide or have calculations on information. So typical ones you'd obviously think about would be aggregates, entities, value objects. They store the data in your system. But you also want to think about commands, which basically hold parameters, domain events, which hold facts about information, data transfer objects, which effectively know about information being transferred outside your system, right? A measurement would be basically an information holder because it would hold a measurement of some kind of device or signal. Structurers maintain relationship between objects and information about those relationships. So collections of all form are structurers. The repository pattern in DDD is just a structurer. Service providers actually do work and provide some kind of computing services. So in DDD terms, that's things like domain services. But also, an entity itself may do work. It may be able to calculate things about the stuff that it holds. Factories or repositories do work in the sense that they create or hold objects. Parsers for parsing text. Request handlers for responding to messages or HTTP calls, etc. All of those things provide some kind of behavior. Right. Coordinators. So coordinators, basically their job is not to do work, but it is effectively to delegate to somebody other. So typical request dispatcher or processor, a message pump in messaging systems, a supervisor and a supervisor worker. These are coordinators. They don't do work. They say this person should do the work. Controllers are kind of related. They make decisions and they direct others, direct actions. So a coordinator is something like a router or a mediator or a state machine or a workflow. So the controller typically might route something and the coordinator I might call a controller to do that kind of routing. An interfacer transforms information between distinct parts of the system. So a facade at the edge of your module where effectively I may translate data from your format into mine, right? Gateways talking to messaging systems or databases, sensors which basically abstract things that are taking readings in industrial environments, right? Web pages are also effectively interfaces for human beings to enter data. And if you think about them in this kind of like model from a ports and adapters model, right? You can see that essentially some are more used inside and out. So typically things like structurers, service providers, and information holders tend to be used within the domain. Things like interfaces, controllers tend to be used more towards the as adapters towards the outside. And controllers and coordinators and structures tend to often get used at that boundary layer. Collaboration is just really this idea that two objects might want to talk to each other. Right, so I've got an object here that knows information, responds to messages, and has operations. It has relationships to other objects, which it wants to send messages to. I may send out a message. I might, for example, be asking it to make a decision, and that object will effectively make a decision and return a response to me. So collaboration is that model with that my role isn't everything. I need to talk to other roles. It will become much clearer for you when we do the example. Responsibility-driven design also has a notion which we call object neighborhoods. Those of you who are a fan of vertical slices, back in the 90s we already had this. It's just called object neighborhoods. And object neighborhoods basically say objects tend to cluster in a group whose job is to do a specific thing, right? Like I'm the claims bit, I'm the underwriting bit, right? And that is a useful organizing principle. And typically, you have a more coarse-grained interface towards the edge of that, some kind of facade and more implementation detail inside, and things outside tend to talk towards the facade. It's an organizing principle for objects. Control styles we mentioned earlier. Centralized, one kind of God object does everything, bad, we don't want that. Dispersed, no matter what we're doing, it all goes off to an individual object. We have to route stuff around to find who's going to pass it. And delegated, we have a number of points of entry which essentially will delegate some work to classes inside. And that delegated model is what we're after and tends to fit with our object neighborhood model. All right. So a few key concepts before we get into a kind of worked example. Key concepts, responsibilities, right? That's something that effectively I know, I do. Roles, a collection of related responsibilities. Stereotypes, pre-packaged structural roles. Collaborations, that is the notion that our objects will talk to each other to get work done. Contracts, what I can expect from my collaboration. And control styles, how I fit a system together. All right, so let's talk about how we actually do this. All right, so I, as well as doing software engineering, I also like role-playing games, and this is one that I produced a new edition of. I didn't write it originally, called Questworlds. I don't need to explain how Questworlds works to you. It doesn't really matter, the purpose of the exercise. But what we're going to model is the idea that I might want to set up a very simple web page to let you manage one of the procedures in the game, which is called a contest. So the first thing we do in RDD is we write a design story. And the design story is the narrative about the system's behavior that we want to begin to break down into objects. Obviously, in domain-driven design land, this kind of narrative should be expressed in ubiquitous language. Okay. We focus on who's involved, what they want to do, how our system supports them. And we say, think like a script on a spec. This is not a classic specification with functional requirements, etc. It's a little narrative. We'll show you an example in a second about what we want the system to do. So here's my little narrative. A GM wants to run a Questworlds contest with a player. They open the Questworlds website and generate a session ID, which they share with their players. The GM creates a new contest by entering the prize, so that's what you're going to get if you win the contest, and setting the target number for the resistance. In other words, how hard is it? A player joins the session and records an ability they believe helped them overcome the obstacle along with its rating. So if the obstacle was the troll, your ability might be hit it with my sword. Right? The GM determines any stretch, situational modifier, hindrances, and augments. Don't worry about that. It's just we can modify the number. The system rolls a d20 for both the GM and the player. So it's a d20-based system. You roll a d20 and you want to essentially get your target number or lower. The system evaluates the results, adjudicates the winner, and determines possible consequences or benefits. So it basically compares the two dice, figures out essentially who has done best. There's a model about you roll under to succeed, roll above you fail. If we both succeed, it's the highest dice roll that wins. That's the simplest way of explaining it. You don't need to know that. But effectively then it can calculate how many, what we call degrees of success you won, what benefits you may get, etc. And then it shares that with the player. So just rather than doing, particularly if you play online, rather than people, there are online dice rollers, but it doesn't do all the math for you. This thing just does that for you, right? Just an example. So that's my narrative. And what I'm going to do with that is I'm going to identify themes. So themes, if you like, are a bit like that object neighborhood idea. They represent key kind of ideas that we think are flowing through that narrative. So you want to look for work you perform, things directly affected or connected to the application, information that flows through your software, decision-making, control and coordination activities, structures and groups of objects, and representations of real-world things. So in that design story, I think the themes tend to be creating a session, right? So we had this whole notion about I want to better create a session. Framing a contest, I was going to enter all the details of the contest, where the GM was, and the player's going to enter their ability they're going to use. Dice rolling, so emulating the idea of us both rolling a dice to try and determine the outcome. And then adjudication, where effectively we would agree what the outcome was and present the results. And those are kind of key themes, right? They are a little bit related to the flow through the application. That's probably a separate talk. But often when we think about behavior, we are thinking about flow. Right. So the next thing to do is to find candidates. So given those themes, and given what happens in those themes, and given my ubiquitous language, what are the candidates? What are the things that I need? And we describe them by what they do, not what they implemented. And we're, remember, focused on behavior. We want to name them, right? We don't want to include pattern names in them. We may look for verbs, basically, because we're doing things. Which makes sense across the life cycle. We shouldn't duplicate adjectives to disambiguate. Synonyms are necessary, but really focus on ubiquitous language. So here I might say, well, what candidates have I got? Well, in session creation, I might have some notion of a session maker. I might want to see previous results. I've got a contest history. I have a notion that when I create something that there's a participant and a prize. Okay. In the contest framing, well, there's some kind of contest runner that basically is going to help adjudicate doing things when I press the button. And there's also notions like a contest, a modifier, and a target number, right? Even though we had specific modifiers listed on the UI, actually we can just generically represent them as a concept called a modifier. As a behavior, it modifies the dice roll. A contest knows about basically the contest and what's at stake and who's the player, what ability they're using, etc. A target number, which is a concept we had in our ubiquitous language, this idea of something we effectively give as a target for the dice roll. Dice rolling, we have a notion of a dice roll or result calculator. Dice roll, success or result, right? And adjudications, we're going to outcome adjudicator and outcome modifier. Now notice we talk about them being candidates. This is just a set of ideas. In a little bit, we're going to try and test that out and refine these ideas better. So we can just pull some ideas out of our ubiquitous language and our domain. We don't have to worry too much if they're right. We just need some candidates to get started. All right. So those are my candidates, a whole load of them basically that I've created. Yeah. All right. Some candidates obviously hold significant domain logic. We may focus on those a lot in the next section. We come to do some feedback on what our model looks like. We don't want primitive obsession, right? So we try and avoid integers and strings and stuff in our model. We want to trait value objects that basically wrap around them. Yeah. Though we have the actual terms in our language like augment, benefit, consequence, we actually can find out that they're all just special cases of modifier. Similarly, we have PC and resistance, but we really only care about participants. If we talk to a domain expert like me on the game, who wrote the game, I can tell you those are just special cases of that generic class. So what we do is create what's called a CRC card. So these are basically 3x5 index cards. And on the front, on the kind of blank piece, we write the purpose. So that's essentially a description of what the purpose of this thing is. So we've got an email address. It's talking about what email addresses are. We write a role. What kind of role is this fulfilling? Remember that we basically said you are going to fulfill one or more roles in the system that have key responsibilities. So what is the role that this thing has, right? Any patterns you might implement, and stereotypes, the kind of structural roles that you may have. And on the back, you're going to write two things. What it does, so what it knows how to do, what actions it can take, etc. And its collaborators, who it is doing that information with. And we do that step by step. I'll show you how we get the steps done. So the first thing you're going to do is just write this side, right? You're going to write basically for your key classes that you want to start modeling, the name of the candidate and its purpose. So we've got the contest runner, which orchestrates the running of a contest, and the outcome adjudicator, which when passed the result for a plan or result for the resistance, then the outcome adjudicator will determine the outcome, victory and defeat in the contest, and any resulting modifiers, consequence, benefits. Stereotype of coordinator, stereotype of service provider. So this one effectively's job is to pass something on to something else, and this job is actually to run some part of our system's behavior. Okay. And then we take one of our use cases. So use cases can be, you can substitute user stories if you like. In a more modern world, use cases, this is the 90s, so everything's about use cases, right? And so our use case, we want to model one of our use cases. We want to run through with our candidate objects. So ours is frame a contest, GM creates one, notes the resistance, sets the target number, determines the ability, determines any modifiers, and we're done, right? We're not going to run through all the way to do contest is complete and everything else. We just want to run a given use case that we have. We're going to use nose decides to some responsibilities and keep them concise and focus on distributing work. So on the back of these cards, we're going to want to write the responsibilities. We can guess at a few now, but we can let the process figure them out for us. So we've got some stereotypes, service providers, interfaces, information holders, controllers, coordinators, and structurers. We know those from kind of earlier on when we're talking about the stereotypes. We may assign early on a stereotype because we know it's going to perform that particular stereotype in the organization. And then what we're going to do is figure out, okay, what are the responsibilities I can think about for all of these? Now, I can't run through all of them for you for time, but it's actually taking a few examples, right? We know that contest runner does the job of facilitating the contest. Outcome knows our degrees of victory or defeat. Result calculator knows how to turn a dice roll into results. Remember, we're doing this, we're focusing on our model of knows, does, and decides, right? So modifier knows an adjustment, right? Outcome, I said does the job there, but really it decides the outcome of the contest would be the way to put it in that frame, right? You can always use different language as long as you're splitting things up. So you've got a few deciders, right? And a whole load of things that are mostly knowers, but that it assigns us our responsibilities. And then we write those on our cards. So our outcome adjudicator knows the player's result, knows the resistance result, calculates the outcome. And the contest runner knows the prize, knows the resistance, knows the PC, knows the target numbers, knows the modifiers, and runs the contest. Okay. And then that will give us a set of collaborators. Because as I begin to think about things that I'm doing or things that I know, that may imply other objects. I may know something which implies that I know about a given object, which is used to represent that. I may collaborate with another object by effectively asking it to do work and giving me a reply, etc. All right. So we go through the stereotype. Does it imply any collaborations? So effectively, if I'm say, a structurer, that's going to imply I'm collaborating with things I structure. We look at the individual responsibilities and say, okay, when I look at the fact that I run the contest, that might imply something. If it's complicated, a big responsibility, does that imply I have, I need to have some other objects which basically implement the responsibility for me? It may be where we apply design patterns. It may be where we make architecture choices. So, information holders tend to be, I tend to need to do serialization. Deserialization, so typically I'm doing persistence from a database, that kind of thing. Structures, there are things I collaborate with. Service providers, maybe I need to have other classes that I basically use to do that implementation. Controllers, I'm probably going to collaborate with sources of information and objects I instruct. And coordinators collaborate with the sources, things that I pass information to, and sinks, the things that give me results. And interfaces, which are a bridge between neighborhoods, I get collaboration between my neighborhood and other neighborhoods. So again, I think about collaborations, pulling a few out. Session manager uses the contest runner, or the outcome adjudicator uses the result calculator. Outcome adjudicator compares the result for the participants to determine the outcome. So you can see that I'm building these collaborations among the objects in order to get that use case implemented. So here I'm now listing out the various collaborations that I would have for that candidate. And then we get to the fun bit. The fun bit is what you do is you take these index cards, you sit around a table, and you play a game. And the game that you play is I walk through the steps of the use case, passing the ball as responsibility moves between the various candidates to map out what's going on. So we might say, you might start with someone saying, I'm a user and I want to create a new session for Quest Worlds. And you pass the ball to someone going, I'm the session maker, and I make sessions. And you might say, but what I do is I create a session. And you pass it to the session object and say, I'm a session. And I know about basically sessions, and I have an identifier. And then the ball comes back basically to the session maker and goes back to the user. So I've fulfilled that little behavior, right? If you want, you can do silly voices. That may make it more fun. I've played this a lot. It can be quite entertaining. Typically what you'll find as you go through is that you're missing loads of stuff, right? You'll go, I give you back a result. What is that? I don't know. We don't have a candidate for that. Okay, we need to write a candidate for that. You may need to explore ubiquitous language and figure out what do we call that thing, right? So typically what you're doing is exploring how you would implement it. If you think about the ball as being the path of execution through your code, you're effectively moving the ball between participants. Generally speaking, to make this game work right, you have to basically distribute some of the key candidates that own major responsibilities around the table. Otherwise, someone ends up talking to themselves a lot. If you find someone's talking to themselves, swap their cards over somebody else, right? But it lets you really cheaply simulate how would these candidates deliver my functionality. It makes it very easy to change because the cost of change is tearing up an index card and replacing it with a new one. All right. So the goal, so you typically run one use case, you don't try and do everything, set boundaries, right? Typically, we tend to worry about the domain model. We don't tend to worry about how am I exposing this as an HTTP API? How am I persisting it to data store? We tend to have a class at the edge that abstracts that idea, and we don't worry about it more than that, right? Because your focus is really the domain here. All the rest of that is pretty much decided for you by the framework, so there's no real point in modeling it. You assign candidates, so participants, role players, one or more candidates. A candidate says what role they perform when asked, when they need to do, and how they know it. Collaborations then flow between them. Simulate the use cases. Use cases are conversations with the system. Okay? Add controllers as needed. All right? So, test the model. Start with an event that represents user intention. Typically, as I said, I tend to start at the port and the port's adapters. Who receives the thing coming in? Are we missing an object? For example, quite commonly, there is no one to receive at the beginning. Everyone's, how do we get started? And everyone's like, well, we get the HTTP call will call the port and give us a thing, and you're like, what is that thing, right? And it might be a game request or whatever, right? So typically that's quite common. You don't have anything in the periphery. Does the receiver have a responsibility to handle it? So sometimes we may say, in my responsibilities, this isn't listed, but it seems natural to us that you would have it. We don't need to create a new candidate. That feels like it's part of your role or part of the roles that you basically implement. Sometimes when we play this game, you may find that you end up with candidates that, quite a lot of the candidates only have one role. Over time, you may begin, as you play, you may begin to realize actually probably one class could have both those roles. And you can either tear up and rearrange so you basically show both those roles, or you just leave them as two classes, but you make some kind of note that probably we think this is implemented by one class. Right. Okay. Sorry. Okay. And you follow the sequence. Typically we use a ball. Typically we like a nice soft ball rather than a hard baseball or anything, because that tends to, or a cricket ball, that tends to get a little bit unpleasant when your colleagues don't fail to catch it. Yeah, you toss the ball to indicate the flow of control. If you have the ball, currently you're the person who should be facilitating that request, right? You run into problems, you're creating new candidates, you tend to try and be critical, right? Because it's very cheap. Final bit you need to do, you come up with all these candidates, you understand how they collaborate, you understand the responsibilities and the roles that they perform, and you have to choose a control style. Generally, you're trying to get towards distributed. Here we have kind of session manager, contest runner. They're the outcome adjudicator would be the main parts of our delegated control style with some collaborators. So it's not too bad. I don't think we really have a God object. Potentially, contest runner feels a bit like that, maybe at times. We might want to think about whether that has too much. But generally, you're trying to move us towards a delegated control style. All right. So it's an iterative style. It's candidates. That's why we say basically candidate rather than class. You work iteratively. You keep refining. You keep running use cases until you get it done. All right. Split over large roles. Introduce new stereotypes. Revisit collaborations or contract boundaries. Names matter. So follow the ubiquitous language of the domain. What would frame a bit than contest runner? So the question is, do we talk about contest runner in the domain, or we talk about framing a contest? Maybe framing would be a better word. We talk about the GM or the referee basically adjudicating the outcome. So should we call that a referee, right? And that may give us basically that greater insight, and that's how you use DDD. So this is what they mean in the DDD book by when they say in model-driven design, assign responsibilities from the domain. This is what they mean, because they're talking about responsibility-driven design. It's just that you don't know that because most people have come to the DDD book in the 21st century, not understanding that in the late 20th century, there's a whole load of foundations that got missed. The good news is it's freely available. Okay, so we have built behavioral model responsibilities and collaborations. So those are kind of the key items you want. If you go to Rebecca's site, you can get her book. Some of you may be, oh, Ian, isn't this all old school, big design up front, and we're agile, we don't do this stuff, right? If you look at the XP, so extreme programming, which is much more agile than, say, Scrum is, right? If you look at it's basically in a development loop, it explicitly includes a CRC card step. So for those of you thinking, I shouldn't be doing this because I'm agile, you are not any kind of agile that the people who did extreme programming understood, because they explicitly did this process. And that is because generally you are working as a team, trying to get something done. So early on, you want to have some kind of team agreement of how you're going to model this. And so this, often called a design or elaboration phrase, is quite lightweight, and it's enough to get you started. They are candidates, by the way, so when you get to implementation, you may say, oh, it doesn't quite make sense, right? We need to do this, this, and this when we actually come to define it in the code, and that's perfectly fine. That's what things like stand-ups are for, to communicate, hey, the design we all agreed on, that isn't actually what we're going to do, because it turns out when we come to try and code this, there are other things we need to understand, and I'm going to share that information with you. All right? And there you go. And that is responsibility-driven design. which is the missing bit of domain-driven design that many of you probably never heard of because you weren't 90s kids like me. Thank you very much.